So I decided to do my research project on XMPP. I picked it because I wanted to study higher level protocols that operate within instant messaging applications. I use WhatsApp a lot, and so I looked into what WhatsApp used, and WhatsApp uses a further extended form of XMPP. The trace files that I used for this, though, I didn't capture myself. I got from those that were taken largely while someone was using an instant messaging application called Adium. And in some ways, that's a little bit better because Adium uses a more vanilla form of XMPP, whereas WhatsApp uses a further extended form that can get pretty hairy and complicated pretty fast. I also had trouble getting those trace files together and limited time to make that happen because I don't own my own network. Now, without further ado, XMPP stands for Extensible Messaging and Presence Protocol. So it's extensible, meaning you can basically add to what's already there. And what makes it extensible is it uses XML. This is actually an XML file we're looking at here. XML is kind of like HTML. You see we have like open and closing tags. But unlike HTML, it's a little bit different in function. Rather than defining visual components on a web page the way that HTML works, XML defines data, and it can also be used to effectively define operations. And so we'll see that with the first couple of examples. For messaging, it's used to send and receive different kinds of messages, be they text messages, a status update, or some sort of notification, emoji replies, and VoIP and video calls as well. For presence is what makes it real time. It's what allows you to basically be in a chat with someone and see if they've read your message or not, to see if they're online, to see when they replied to your message, if they've replied to it, or if they read it, or if they've changed something in their profile. It typically operates on top of TCP at the transport level on port 5222, and Wireshark is configured to recognize this. But it can also run on UDP for the VoIP and video call stuff. Since this is just an introduction, though, we'll only cover some TCP examples. XML operates with the top level tags are called stanzas, just a name. Three of the most common ones that we'll cover are stream, message, and IQ. We might also cover a little bit of presence later. Stream, an opening tag opens the stream. So this will be represented by a single packet in Wireshark. And then if the client or server, for whatever reason, closes the stream, it'll send one of these, and that'll show up as a separate packet within Wireshark. So some of these are designed to show up as one packet. Some are kind of separated, just depending on how it works. So here's a few basic examples. Here's a client opening a stream. You'll see Jabber in these a lot. XMPP actually used to be called Jabber until they changed the name. And so client opens a stream and the client closes a stream. So we'll go over to Wireshark briefly. Be back and forth from there. And we'll look at a quick example. So I'll filter really quick for XMPP. This is actually the same example that I just showed in the XML itself. If you see this caret to the right, that indicates it's going from the client to the server. If it's the other way around, it's from the server to the client. You can also tell this by seeing the source and port destination numbers, but in case you didn't already have those for your columns, you'll see a dynamically generated source port heading to XMPP's proprietary port. So this is the same one that we just saw for an opening. This one is a response. And in this case, there's an inner tag called features. And it says, yo, we need you to start TLS for the encryption if you're going to connect, Mr. Client. And for mechanism, it states the kind of higher level encryption it wants. And the client's like, yo, we want to start TLS. And then the server's like, yo, let's do it. And then it just goes through the TLS handshake. And then proceeds to run a bunch of stuff, like send data back and forth between each other. Fun stuff. Ooh. There we go. I'll close this one for now. Moving on. So the message jag is pretty common. I pulled this out of a simple sending message example, which we'll look at in Wireshark. If these are examples of user composing a message, so you have different kinds of messages depending on whether it's composing. This is how someone knows that they're typing a reply, like your interlocutor online is typing a reply. This one lets you know whether this active. If there's no body, indicates, oh, they're in the chat. Like they've seen it. This body indicates that there's data in it. And then if you see a from tag anywhere, that indicates that it's being sent like to you from the server typically. And this too doesn't necessarily have to be you as the user. So if you were in like a group chat and they marked it specifically to somebody, then it would pop in there. And you'd see there's that. But you could theoretically, if it was to everybody, you could take this 2 out and it would just send it to everybody and you'd see, oh, this is who it's from. Fun stuff. So we'll go into Wireshark and look at this one actually. So I won't show everything, but a quick, simple filter. If you somehow manage to get XMPP unencrypted, you just use this one, XMPP message body for your filter. You just go down, go to the body, read that message, read the next one, read the message, and you could read someone's whole chat and whatnot. And so all of those ones that were in the example were also taken from this message one. A third thing that we're going to look at is actually information queries, or IQ. And IQ, they serve various functions, basically to get information back and forth. In this case, this is a create operation. And so if we're thinking CRUD, and so this one is just basically setting a nickname, a display name for the user. So it operates with this concept called pub/sub. So pub/sub is publish or subscribe. So you publish changes to your profile thing, and if someone puts this pub/sub with like a subscribe, it would have information rather than what is changed, than who is being added to their contacts. And that's also one of the changes that you can see in more complex situations where someone is like, oh, I don't want to receive constant notifications from this person. So they'll change that within their subscription. But all of the examples in these were generally of the publish variety rather than the subscribe variety. And this is just a server response indicating that it happened. So we'll look at the trace file that these came from. We'll just filter by XMPP, even though we don't really need to because there's like 4 things there. So we're going from the client to the... And actually, going from the client to the server, it's like, yo, get my nickname. Do I have a nickname? Nope. So it'll check that before adding in one for the first time. It'll send an error back, basically just saying, yo, you don't have a nickname. And then you set the nickname. And in this case, it sets it to tom-nickname. I actually pulled this one out for that file we just looked at. And then this one, IQ result, I wouldn't say I'm an ultra expert on this protocol, but the fact that this doesn't say error, I think indicates that the person actually was successfully able to update their nickname. Now we're going to look at presence a bit in this add contact one. So presence within this concept, because I think it's important to cover. Presence here indicates that this person is trying to subscribe. And then there's a bunch of information queries back and forth with all the info that will need to be sent for the first time for that subscription to happen, for someone to basically add someone to their contact list. And then eventually, and you'll actually see, if you look at longer, that here's an indication that the user was able to subscribe to add the other user to their contacts. This one, you'll see a lot of these files, you'll just see presence ones going back and forth. indicating, oh, I'm online, I'm not online. Anytime that there's like a change or any periodic packet being sent back and forth just to see if there are any changes. So you'll see if you do any actual XML tracing yourself, you'll see it's probably actually about half of them are these presence tags, just indicating things being sent back and forth. A quick note, just back on the extensibility thing with that. With this pub/sub functionality and with the presence and the information being sent back and forth, different applications handle contact information differently. And for example, with WhatsApp itself, I unfortunately don't have any examples for this, but I think it's interesting to cover. You'll have some accounts that are actually business accounts, and so that becomes highly important when subscribers are seeing it. So the pub sub will go back and forth with a higher level of customization, because what's published on the business account will have all sorts of more information, including like a full list of their products and whatnot. If there are discounts, if an advertisement came out, little things like that. That aren't necessarily automated messages. They're just things that you would know if you like clicked on that business account. And so that's one of the ways that it uses the extensibility, and including the subscribe. I don't know if I covered this earlier, but the subscribe one, for instance, say you muted notifications for someone, you still need to be able to see their message, but that will change your setting in subscription. So that would change under what circumstances the presence tags go back and forth. And so that's just XMPP in a nutshell, and that was my research project.